All right, welcome back to the deep dive. You always bring us the most interesting stuff to dig into, and this time is no exception. We've got this paper, "The Psychometric Modeling of Scientific Reasoning: A Review and Recommendations for Future Avenues." It's by Peter A. Edelsbrunner and Fabian Dablander.
Yeah, it's a really fascinating paper published back in 2019 in the Educational Psychology Review.
And it really got us thinking about how we understand and measure scientific reasoning.
Yeah, and it's such a crucial skill, right? Like how do we actually get at that? How do we measure how well someone can think scientifically? And this paper kind of takes us down this rabbit hole of psychometric modeling. It's looking at the methods we use and maybe some of the shortcomings or blind spots we might be missing.
Okay, so psychometric modeling. I mean, that sounds a little jargony. But the paper actually puts it pretty simply. They say it's modeling the encounter of a person with an item. So basically, how do we connect these sort of abstract ideas like scientific reasoning to how we actually try to assess it with, tests or surveys?
Right, exactly. It's like how do you go from can someone think scientifically to how do we capture that in the way they answer these specific questions? And a big part of that is looking at how people respond to different questions,
Yeah.
looking for those patterns, to reveal those underlying abilities.
So it's not just about individual questions, but about the connections between them, like how the answers to different questions might relate to each other.
Yeah, totally. It's about using statistical tools basically to figure out what's going on beneath the surface, like what skills or traits are making people answer questions in a particular way. And what's really interesting here is this paper kind of lays out two main camps in the field, two schools of thought about how we should be measuring things.
Right. The Rash School and the IRT School, which stands for Item Response Theory. And the paper points out that they've got, some pretty different core ideas about measurement. So in a nutshell, what's the big difference in their thinking? What are they arguing about?
So the Rash School, they're kind of like the purists, right? They're very much focused on this one specific type of model, the Rash model. And these models have a very particular structure. They link the difficulty of a question and a person's ability in a very direct way.
Okay, so it's like a one-to-one relationship. The harder the question, the more ability you need to answer it correctly.
Exactly. And a big part of this is that the difficulty of a question is seen as fixed, no matter who's taking the test. It's like a perfectly built staircase. Each step is exactly the same height.
Okay, I'm getting that picture. So for the Rash School, there's this very clear idea of what good measurement is. Now, how does the IRT School differ from that? What's their philosophy?
Well, the IRT school, they're a bit more flexible, you could say. They use a wider range of models. And these models, unlike the Rash model, don't necessarily assume that question difficulty and person ability have this purely additive relationship.
So it's not always a straight line.
Right. Like, a common IRT model, the 2PL model, it allows for questions to have different discrimination levels, meaning some questions are better at telling apart people with different abilities. They're more sensitive to those differences.
Ah, so it's like not all the steps on the staircase are the same height. Some questions are just better at, sorting people out. And the paper mentions that this leads to ICCs, item characteristic curves, that can overlap,
Yeah.
which is different from the Rash model where they're always parallel. So what's the significance of this overlap?
The overlap basically shows that, well, the relative difficulty of two questions, it can actually change
Yeah.
depending on the ability level of the person answering them.
Oh, interesting. So the same question might seem harder or easier depending on who's answering it.
Exactly. Think about it. You've got a really easy question and a moderately difficult one. For someone who's really struggling, that moderately difficult question might seem impossible. But for someone with high ability, the difference between the two might not be that big.
Right, right. So the Rash School, they would say that's a problem because the difficulty of a question should be, inherent, a fixed property, no matter who's answering it.
Yeah. It's like they want a measuring stick that's always the same length.
So these different ideas about what good measurement is, they lead to different ways that researchers actually use these models, right?
Absolutely. So the Rash School, they tend to see the Rash model as the ideal, even the correct model for measurement. And if the data they collect doesn't quite fit, they assume the problem is with the data, not with the model itself.
So they're really sticking to their guns.
Yeah, they really emphasize making sure the data fits the Rash model. They use these things called item fit statistics to identify questions that don't fit and sometimes even remove them.
So it's like trying to jam a square peg into a round hole.
Yeah, kind of. They're trying to get everything to line up perfectly with the model. Now, the IRT school, they take a different approach. They're more data-driven. They want to find the model that best explains the data, even if it means going beyond the rash model.
So they're a bit more open-minded.
Yeah, they're willing to consider different IRT models that might better capture the patterns in the data, even if it means relaxing some of those strict rules of the rash model. They're not so focused on making the data fit one specific model.
Okay, so we've got these two very different ways of thinking about measurement, leading to different approaches in research. Now let's get to the heart of what this paper is arguing. What's the central tension they're highlighting? What's the problem?
The problem, as they see it, is that the rash model is super dominant in research on scientific reasoning. And this is often mirroring what's happening in large-scale educational assessments like PISA and TIMSS, those big international tests.
Right, right. So the way we're measuring scientific reasoning and research is very much influenced by these big standardized tests.
Exactly. And the paper argues that this heavy reliance on the rash model can actually create some limitations. It might lead us to a too simple or even inaccurate understanding of what scientific reasoning really is.
So even though scientific reasoning is this complex thing with many different parts, the tools we're using are kind of pushing us to see it as this one-dimensional thing because the rash model is so prevalent.
Yeah, that's the idea. The strictness of the rash model, especially when combined with this focus on item fit statistics, can lead to a really narrow interpretation of what's going on, both statistically and psychologically. We might be missing the nuance.
And this heavy reliance on item fit statistics to decide how many dimensions, how many different skills are involved, that's something they really question, right?
Yeah.
Like they're saying those statistics might not be very good at telling us how complex something really is.
Yeah, that's a key point. They actually did some computer simulations to show how these item infit statistics, which are, really commonly used with the rash model to see if a question fits, they can actually fail to detect when there are multiple abilities at play.
Wait, so researchers might think that their data fits a one-dimensional rash model based on these statistics, but in reality, it could be much more complex. Like scientific reasoning could be made up of several distinct but related skills, and we're just missing that because we're forcing it into this one box.
Exactly. It's like we're oversimplifying it because of the tools we're using,
Yeah.
and that could have some real consequences.
Because if we're seeing scientific reasoning as just one big thing, we might be missing important differences between its various components. Like the paper talks about things like generating hypotheses, designing experiments, evaluating evidence, and they even connect that to the scientific discovery as dual search model.
Right. And those different aspects of scientific reasoning, they might develop at different rates or be influenced by different factors. They might require different teaching approaches. We're missing all of that if we just limp it all together as one thing.
Okay, so big takeaway here for everyone listening. The rash model, it has its strengths. It's good for large-scale comparisons, putting things on a common scale. But we have to be cautious about over-relying on it, especially in research on something as complex as scientific reasoning.
Right. It's not the be-all and end-all, and we have to be aware of the potential downsides, the potential for oversimplification. It might be giving us a picture that's too neat and tidy.
So, it makes you wonder, if researchers are so focused on this one particular model, are they potentially missing out on insights that other statistical methods could provide, like, the broader family of IRT models or other approaches that might be more flexible, better at capturing the complexity?
Totally. The paper talks about some alternatives like cognitive diagnosis modeling, which can give you a much more detailed look at the specific skills and abilities involved. You can really start to tease apart those different components of scientific reasoning.
And see how they relate to each other in more nuanced ways, not just as this one big blob.
Exactly. It's about using the right tool for the job.
So, bottom line, this paper is really urging researchers to think more carefully about the models they choose, not just defaulting to the rash model every time, especially if they want to really understand the nature of scientific reasoning.
Yeah. They're advocating for a more deliberate approach, where the choice of model is guided by the research question, not just by habit or convenience.
And that means considering whether scientific reasoning is likely to be a single skill or multiple skills, and being really rigorous about how they test if the model actually fits the data, not just relying on those item infit statistics blindly.
Right. It's a call for more diversity in our methods and for a deeper understanding of the tools we're using. What are the assumptions built into these models? And are those assumptions valid?
So more variety and more critical thinking about how we measure things. And I think this applies not just to scientific reasoning, but to any complex skill or ability we're trying to understand.
Right. Absolutely. And that brings us to our final thought for today. Think about the claims you hear about, about intelligence or creativity or emotional intelligence. How are those things being measured? What models are being used? And could those models be oversimplifying things? Are we losing important details because we're so focused on a single score or a one-dimensional view? It's something to keep in mind. How we choose to measure things really shapes what we think we know.
So a little healthy skepticism never hurts. Always question the tools and the assumptions behind the measurements.
Exactly. Think critically about how we measure, and you'll understand the world a little bit better.
Great stuff. Always a pleasure. And to our listeners, thank you for joining us on the Deep Dive.
Until next time.
See you then.